Imagine your car engine losing every drop of oil in just minutes. One tiny rubber seal silently prevents that disaster every single day. Most people never notice these hidden rings, yet modern cars, airplanes, factories, and hospitals simply could not operate without them. Think about this. A simple gasket only a few millimeters thick can survive crushing pressure, intense heat, freezing cold, and constant vibration. But here's what nobody tells you. Making one perfect seal demands astonishing chemistry, precision engineering, and thousands of quality inspections. Every year, factories produce billions of rubber seals, each one designed to stop leaks that could destroy machines worth millions. Some seals work deep beneath the ocean. Others survive rocket launches where temperatures and pressure change in an instant. And this is where it gets truly extraordinary. The journey begins long before any factory machine ever starts spinning. Natural rubber flows from tropical trees, while synthetic rubber begins inside enormous chemical plants powered by science and heat. Imagine thousands of ingredients measured so precisely that one tiny mistake could ruin an entire production batch. You can already smell warm rubber, hear powerful mixers roaring, and feel the factory vibrating beneath your feet. What happens next surprised even experienced engineers, because every ingredient must bond at the perfect molecular level. In the next stage, we'll travel from tropical forests to chemical refineries and uncover where every remarkable ingredient truly begins. Our journey starts in Thailand, Indonesia, and Vietnam, where millions of rubber trees quietly supply much of the world's natural latex. Every careful cut releases milky latex that slowly drips into collection cups, producing only a small amount from each tree daily. One mature tree may produce about 2 to 3 kilograms of dry rubber each year, making every harvest surprisingly valuable. But natural rubber tells only half the story. Many modern seals rely on advanced synthetic materials engineered inside giant refineries. Factories transform crude oil into butadiene, styrene, nitrile, and other building blocks that become incredibly durable synthetic rubber compounds. Imagine raw materials traveling thousands of kilometers by truck, rail, cargo ship, and container before reaching one manufacturing facility. Inside the factory warehouse, technicians inspect every shipment before a single kilogram enters the production line. Most people never think about carbon black, yet this fine powder gives rubber its famous strength, color, and wear resistance. Sulfur arrives next, followed by zinc oxide, processing oils, waxes, antioxidants, and carefully selected performance-enhancing additives. Each ingredient must meet strict purity standards, often exceeding 99%, before engineers approve production recipe. Even tiny contamination can weaken an entire batch, causing expensive failures months after the product leaves the factory. And this is where the real transformation begins, because these ordinary ingredients will soon become precision-engineered components trusted around the world. Now the real manufacturing begins. Powerful internal mixers combine rubber and additives at nearly 150 degrees Celsius, or 302 degrees Fahrenheit, with incredible force. Inside the sealed chamber, twin rotors spin at around 40 revolutions per minute, squeezing every ingredient together for nearly 6 minutes. The immense pressure and heat ensure every particle blends into a perfectly uniform compound. You can hear the deep roar of machinery, while the warm scent of fresh rubber fills the entire production hall. The floor vibrates beneath your feet as these massive mixers transform raw ingredients into a high-performance material trusted around the world. The finished compound drops onto giant cooling rollers, where rotating steel cylinders quickly reduce its temperature before the next stage. As the thick rubber sheet moves across the rollers, it becomes smooth, consistent, and ready for precision processing. Workers carefully inspect every sheet before automatic cutters slice the compound into precisely measured strips for molding. Every strip must have the correct thickness, because even the smallest variation can affect the final seal. Next comes compression molding. Hydraulic presses close with forces exceeding 200 tons, shaping every seal inside precision machine steel molds. The molds define every groove, edge, and sealing surface with incredible accuracy. During curing, temperatures reach about 180 degrees Celsius, or 356 degrees Fahrenheit. At this stage, sulfur atoms create strong molecular crosslinks throughout the rubber in a process called vulcanization. This chemical transformation gives the material its remarkable strength, flexibility, and long-term durability. Think about this. Without vulcanization, the rubber will remain soft, sticky, and far too weak to survive inside powerful engines or industrial machines. This single process completely changes the material's performance. After several minutes, the molds open and robotic arms carefully remove the freshly formed seals. Workers inspect every batch immediately, looking for incomplete filling, trapped air, or any visible imperfections before production continues. Tiny flashes of extra rubber remain around the edges after molding. Precision trimming machines remove every unwanted fraction of a millimeter, leaving each seal with perfectly clean and accurate dimensions. Some manufacturers use cryogenic deflashing, where liquid nitrogen cools the rubber to extremely low temperatures. The thin excess material becomes brittle and breaks away cleanly without damaging the finished seal. The parts are then washed and dried to remove dust and manufacturing residue. Conveyors carry them smoothly toward the next department, while sensors monitor production speed and product flow in real time. At this point, every seal may look identical to the human eye, but appearance alone means nothing. The toughest challenge still lies ahead. What happens next surprises even experienced engineers, because making a rubber seal is only half the job. Proving that every single one can perform flawlessly under extreme pressure, heat, chemicals, and years of continuous use is where modern manufacturing truly earns its reputation. Every year, manufacturers produce tens of billions of rubber seals and gaskets. These small components may seem insignificant, but together they keep the modern world moving. Without them, countless engines, machines, pipelines, medical devices, and industrial systems would leak, fail, or shut down completely. The global sealing industry generates tens of billions of dollars in annual revenue and continues to grow as transportation, renewable energy, automation, and advanced manufacturing expand across the world. Demand for high-performance sealing solutions increases every year because today's machines operate under higher temperatures, greater pressures, and more demanding environments than ever before. China leads global production, followed by the United States, Japan, Germany, and India. Together, these manufacturing powerhouses supply industries ranging from automotive and aerospace to construction, food processing, pharmaceuticals, marine engineering, and renewable energy. Hundreds of thousands of engineers, technicians, machine operators, laboratory specialists, and logistics professionals work every day to ensure these precision components reach customers with consistent quality. Behind every finished seal is an enormous network of plantations, chemical producers, transportation companies, research laboratories, automated factories, and quality control experts. Did you know that a single passenger aircraft contains thousands of seals protecting its fuel system, hydraulic circuits, engines, landing gear, doors, windows, and cabin pressure? Every one of those seals must perform flawlessly throughout thousands of flight hours. Here's another surprising fact. Some advanced sealing materials continue performing at temperatures above 300 degrees Celsius, while specialized compounds remain flexible in freezing Arctic conditions below -50 degrees Celsius. The same basic engineering principle protects everything from offshore drilling equipment to satellites and space vehicles. Electric vehicles have created an entirely new generation of sealing technology. Modern battery packs require highly specialized rubber components to keep out water, dust, road salt, and vibration while protecting sensitive electrical systems throughout the vehicle's lifetime. Over the past 50 years, rubber seal manufacturing has evolved dramatically. What was once a largely manual process has become one of the most advanced examples of precision manufacturing, combining robotics, artificial intelligence, laser measurement, automated inspection, and sophisticated material science. Researchers are now developing next-generation elastomers that last longer, resist more aggressive chemicals, reduce friction, improve energy efficiency, and even incorporate smart materials capable of monitoring their own condition. These innovations could transform industries over the next decade. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, refined through chemistry, shaped by immense pressure, strengthened by heat, perfected by advanced technology, and approved through some of the strictest quality standards in modern manufacturing. What looks like a simple rubber ring is actually the result of decades of engineering, scientific research, precision machinery, and skilled craftsmanship. Hidden inside engines, factories, aircraft, hospitals, and power plants, these components quietly perform one of the most important jobs in modern engineering, keeping the world sealed, safe, and running. That's not just a product. That's a masterpiece of human engineering. If you enjoyed exploring the hidden world of rubber seal and gasket manufacturing, tell us in the comments which factory you'd like to visit next. Don't forget to like this video, subscribe to the channel, and join us for another behind-the-scenes journey into the incredible world of modern manufacturing. We'll see you inside the next factory. The manufacturing process may be complete, but the most important stage begins now. Every single rubber seal must prove it deserves to protect machines worth thousands or even millions of dollars. The journey starts with automated visual inspection. High-speed AI vision cameras capture thousands of detailed images every minute, searching for tiny defects that are almost impossible for the human eye to detect. Even a microscopic crack, bubble, or surface flaw can cause a seal to fail under pressure. Next, precision laser measuring systems verify every critical dimension. Engineers expect tolerances as small as plus or minus 0.05 millimeters. If a seal falls outside that limit, the system immediately marks it as defective. As each part moves along the conveyor, powerful sensors compare its shape with the original digital design. Within a fraction of a second, high-speed air jets remove defective parts from the production line, allowing only approved products to continue. Most modern factories reject fewer than 2% production, but manufacturers understand that even one faulty seal can cause catastrophic equipment failure. That is why quality always comes before production speed. The approved samples now enter the testing laboratory. Compression testing machines repeatedly squeeze each seal thousands of times, simulating years of real-world operation inside engines, hydraulic systems, and industrial pumps. Engineers carefully monitor how well each seal returns to its original shape. Next comes pressure testing. Stainless steel chambers expose seals to several bars of pressure, while advanced sensors monitor for even the smallest leak. If pressure drops by the slightest amount, the part fails immediately. Temperature testing pushes a material even further. Some seals are frozen below minus 40 degrees Celsius before being heated above 200 degrees Celsius in the same testing cycle. Despite these extreme changes, the material must remain flexible, strong, and completely leak-free. Chemical resistance tests expose the rubber to engine oil, fuel, hydraulic fluid, salt water, acids, and industrial chemicals. Engineers verify that the material maintains its strength without swelling, cracking, or losing elasticity after long exposure. Durability machines continue cycling test samples for days or even weeks, recreating years of service inside demanding industrial environments. Every result is carefully recorded and compared with strict engineering specifications. Although robots perform nearly every inspection, experienced technicians still play a critical role. Years of experience allow them to recognize subtle imperfections that automated systems occasionally overlook, proving that human expertise remains an essential part of advanced manufacturing. Only after passing every inspection and performance test do the seals receive final approval. Many manufacturers operate under internationally recognized quality systems, such as ISO 9001, ensuring consistent production and traceability from raw material to finished product. Finally, the approved seals move to automated packaging lines, where robotic systems count, label, and seal each package before shipment to customers around the world. But the story doesn't end inside this factory. These tiny components are about to begin an incredible journey across continents, powering automobiles, aircraft, medical devices, factories, and even spacecraft. And when you discover just how many are produced every year, the numbers are almost impossible to believe.